All right, so the warm-up is on your screen in this video. So take a moment, pause the video, and complete the warm-up, and then play it and see how you did. Okay, so this is a little bit of one variable stats. So we have some data here. It represents the number of days of rain in Cardiff is recorded each month. And then they give us some information. They tell us the median of the number of days of rain per month is 10. So to find the value of x, we have to figure out where does that value of x fit into the order, because the median is relying on the order of the data. So if we were to take a look here and to put the numbers in order, we have to figure out where does that x fit in. And so if the median is 10, that means it has to be between the 8 and the 11. So then thinking about, okay, so if that value of x is between the 8 and the 11, then as we look at counting our way into the middle, right? So marking off one on each side as we work our way in, figuring out where that median is going to be, it's going to be the middle of those two values. So thinking about the median, it would have to be you add those two up, divide by 2, and that equals 10. And if that's the case, x plus 11 divided by 2 equals 10. Multiply by 2 on both sides. We end up with x plus 11 equals 20, which means subtract 11 and you get 9. 9 would have to be the missing value. And if that's the case, if 9 is the missing value, then we have all the data. And then for part B, you're just using one variable stats. So type in all those values into your into a list, run a one variable stats, and you can find the standard deviation. Just remember that is sigma x. And then your interquartile range is taking Q3 minus Q1, which would be 13 minus 8. So the answer to number 2, B part 2 is 5. Standard deviation to 3 sig figs, 2.69 would be the 3 sig figs. Okay, so today is an introduction to this test called a chi-squared test. And this is the other main statistic we calculate with two variables. Correlation is one relationship we look into. Chi-squared is going to test another relationship. It is not testing correlation between two things, but it is testing another relationship. So we're going to do an introduction, go through an example, and then really from here until the end of the unit, it's about chi-squared. So you're going to get plenty of practice with this. I know working through videos is not ideal, but you're going to have an opportunity to work through plenty of examples and get the practice you need. Okay, so calculating and interpreting chi-squared, a little introduction. So chi-squared, we're going to look at testing the relationship between whether or not you went Black Friday shopping is related to, or in this case, we're going to classify it as independent, is the likelihood that someone went shopping on Black Friday related to whether or not they're male or female, right? So is gender independent of whether or not you went Black Friday shopping? So just to clarify, chi-squared is pronounced chi, not chai. Okay, it's chi-squared. Get that in your brain now. It's not chi squared, it's chi-squared. Okay? If you're familiar with NPR, Kai Ryssdal, he's the host of Marketplace on NPR. There he is. It's pronounced as his name, Chi. Okay, so chi-squared test of independence. So this is a test we use to see if two things are independent, if the occurrence of one of them does not affect the other, right? So independence. One thing does not affect the occurrence of the other. So some examples that we might use chi-squared for would be income and voting intentions. Is income independent of voting intentions? Right? Gender and occupation. Does gender impact your occupation or vice versa? So these would be just two multiple examples of looking at two variables. So class year versus employment status. Gender and whether or not you watch football on Thanksgiving Day. Right? These are all looking at two variables and figuring out, is there some sort of relationship, and in this case specifically independence. Okay? Chi-squared, this test, right? So here's the formal notation. This test examines the difference between what you observe and what we would expect out of a data set. And it is an indication whether or not those two things that we're observing are independent of each other or not. That's the big connection here. The big relationship is independence. It's not, are these things correlated? It's, are they independent? Okay. So this is the formula. We'll get back to that here soon enough. But there's a process that we can use similar to how we calculated correlation and how we calculated standard deviation to help us work through the calculations of chi-squared. Okay. So on your paper, you'll notice you have a couple tables, one that looks like this. And this is a 2x2. We call this a contingency table of observed frequencies. This is the data that you would collect, right? So this is the observed data that we collected. And I'm going to be honest with you, I'm just going to make up some data, but I want you to put this on your paper as well. So let's pretend like we observed this data. I took a survey and found that there were 55 males who went Black Friday shopping. There were 60 females who went Black Friday shopping. And then over here it says 70. So 70 males did not go and 65 females did not go. So this is my observed data. This is the data I collected and I had to tally up and put into a little table like this. And now we have something to work with. So the first thing I want to do is I want to just add up all the rows and columns. So my first row, male, there's 125 males. There also ends up being 125 females. Okay, that's not always going to happen. For people that went Black Friday shopping, 115. And for people who did not go Black Friday shopping, there's 135. So the total number of people I surveyed would be this cell right here. And that is 250 people total that I surveyed for this calculation. Okay. So what we need to take a look at is we're going to take a look at the observed frequencies and then what we call the expected values, what we would expect to occur based on the totals of this table, right? So we're going to look at the difference between the observed and the expected outcomes that we would have for this table. So that second table you have, the sums should all end up being the same. So notice I just filled in the sums because the sums should add up to the same amounts. So in that second table, it says expected frequencies. So to calculate an expected frequency, there's a formula, and it's right below that table on your paper. This formula is how we calculate an expected value for an expected frequency table. So for example, this cell right here, for male who went Black Friday shopping, I'm going to take the row total, so 125, and I'm going to take that and multiply by the column total, so 115, and then I'm going to divide by the table total, 250. So notice that formula down here, it says row total times the column total divided by the table total. So that calculation gets me 57.5, and that is the expected number of people based on my total data that I would expect to have gone shopping and be male on Black Friday. Okay, so I'm going to do those same calculations for the next three cells. So the other cells in the same chart, I need to make that same calculation, but the values change. So in the next calculation, I'm now using still the row total, so it's still the same row, so 125 times 135, which is this column total, and then still divided by the table total, so 67.5. Those same calculations are made for the next two cells, except I'm now using the females row total, which in this case is still 125. So those two calculations look like this. And they look fairly similar to the previous two. That's just how this example is working out so far. Okay. So you can continue on to the next video to see the formal chi-squared calculation process. There's 7 steps that we're going to talk about.